In the following few videos, we will update the create user web service endpoint by adding a list of addresses to the user object, so that during the registration process, user can provide their shipping and billing address details. The user object will now contain a list of addresses object, and when user object is persisted to our database table, the list of addresses will also be automatically persisted to its own database table called addresses. And to be able to implement this functionality, we will need to understand some of the GPA entity relationships to make this behavior possible. If the application we are working on is very small and there is no other information but user details that we need to store in our database, then maybe having one database table is sufficient enough. But most of the times, especially when new application features need to be implemented, the data that needs to be stored cannot be efficiently stored in one single table. And in this case, we will need to normalize our database tables. And normalization is the process of organizing data in database. And this process includes creating and establishing relationships between those database tables according to the rules designed both to protect the data and to make the data more flexible by eliminating redundancy and inconsistent dependencies. For example, if additionally to storing a list of addresses which user might have, we needed to store a new blog post that this user has published, we would also need another database table which will be used to store the details of a published blog post. And trying to store a list of blog posts in the same users table together with all other details that user has, like for example email address and password, this will be very inefficient. When we organize information in our database tables, we need to also create relationships between these tables and the data that they hold. And this is needed so that we can later figure out which blog posts stored in the post database table belong to which user, and similarly, which addresses in the addresses table belong to a currently logged in user, for example. So there are different types of relationships that we can create between the database records. For example, one-to-one relationship, and an example of it will be one user can have only one spouse. Or one-to-many relationships where one user can have many social network accounts. For example, one user can have Facebook account, Twitter account, Google Plus account, and so on. Or many-to-one relationships where we have many social network accounts that can belong to one user. And many-to-many relationships where we have, for example, many friends that can have many friends. Let's look at the example of our users table. Now, when we need to store a list of addresses that this selected user has, we will need a new database table which will keep a list of addresses. And each record in the addresses database table should be linked back to a user record, so that when our database has thousands of users and thousands of addresses, we can figure out which address belongs to which user. And in the example on my screen, the user database table has only one record and its database ID is equal to 1. This user can have many addresses, and thus the relationship is one-to-many. One user can have many addresses. The address database table below, which is called addresses, has only 2 records, and each record is linked back to a user record by the field called users ID, where the prefix users stands for the name of the users table, and ID, which comes after the underscore, stands for the field name from the users table. And the value in this field is used to link these records together. Now, looking at the records in the addresses table, we know which address belongs to which user. The good news is that because we are using Spring Data GPA in this project, we do not need to write SQL code to create addresses table ourselves, and we do not need to write SQL code to insert a list of addresses into addresses table. To make it work, we will need to include addresses entity to a user entity Java class and add GPA annotations to create the needed relationships between records in the users table and the records in the addresses database table. For example, have a look at how we will include the address entity into the user entity if we were creating one-to-one relationship. When we establish a one-to-one relationship, we tell that this user can have only one address. And now have a look at how we would annotate the address entity to establish a one-to-one relationship and to create a joined column in the addresses table, which will keep the value from the users table with which these two records will be linked together. The joined column will hold the value of a database record ID field from the users table. And when talking about this addresses table, the value stored in the joined column called users ID will be called a foreigner key. Now let's have a look at the relationship between user entity and the address entity if we were to establish one-to-many relationship, which means that one user can have many addresses. And in our following videos, we'll be implementing one-to-many relationship for our API. Our user will submit two addresses when creating their profile, and both addresses will then be persisted to addresses database table. Have a look at how we will create user entity database table. We will add a new class field, which will contain a list of records of address entity data type. We will then annotate this class field with a one-to-many GPA annotation, which means that one user can have many addresses. And we will specify that when insert operation takes place, we need it to cascade and persist the list of addresses as well. And this will work well for a delete operation as well. If we send HTTP delete request to delete a user, a list of addresses linked to this user will also be deleted. And we also specify that these records will be mapped by a field in the address entity object, which has a name user details. And now have a look at how we will annotate the address entity Java class. We will add a user entity class field, and we will annotate user entity with many-to-one annotation. And this is because many addresses can belong to one user. And we will annotate this class field with a joined column GPA annotation specifying the column name, which has a value users underscore ID, where users is a name of the database table and ID is a name of the field that holds the primary key. Okay, so let's continue now and update our Java code to support this functionality, and we will let user submit a list of addresses in the create user HTTP post request, and we will persist this list of addresses in a new database table called addresses.